When working with functions and relations, we often want to know what inputs and outputs are valid. The inputs are known as the domain, and the outputs are known as the range. The domain of a function is the set of input values. These are usually x. The range is the set of output values. These are usually y, or f of x. When finding the domain and range, it's simple if you're using a discrete function such as this. The inputs are the domain, and we simply list them out. Here, the domain is 2, 3, 5, and 7. These are the numbers that you can input into the relation, and you'll get an output. It's important to know that each individual input is an element of the domain, and that the word domain refers to all of the inputs as a collection. The range is similar. We simply list out the elements 1, 3, 6, and 9. These are the numbers that the relation can output. Once again, each individual output is an element of the range. The word range refers to all of the outputs collectively. It's pretty easy to list the domain and range if you have a discrete relationship, but what if you have a continuous one? Consider this rule, f of x equals x squared. You could input any kinds of numbers, positive numbers, negative numbers, decimals, fractions, even numbers like pi, or the square root of 2. So how do you determine the domain and range of this? Well, the secret lies in the graph. A graph is the window into the soul of a function, and you can learn a lot about the domain and range by looking at its graph. Let's take a look at how we can use a graph to determine the domain and range. Here we have the graph of a relation that shows us the series of inputs and outputs. To find the domain, we look across the x-axis, because remember, the inputs are the x values. We move across the graph until we hit the very first input value. We find that here at -4. That's where the domain begins. It's the smallest value we can input into this relation. We continue to move across the graph. We move across the graph until we find the very last input value. Here we found it at 7. 7 is where the domain ends. You can input any number between -4 and 7. That tells us that the domain is all real numbers between -4 and 7 inclusive. We can write that using a variety of set notations. And remember, it means that you can input any real number between and including -4 and 7 into this relation. And when you do that, you'll get a corresponding output. And so we've now determined the domain to be from -4 to 7, inclusive. That tells us the valid inputs. Now how about the range? Well, when we talk about range, we're talking about the set of output values, or the y's. We'll use a similar process, but this time we're going to look along the y-axis. We'll start at the bottom and work our way up until we hit the very first output. Here it is at -4. The smallest number that this relation will output is -4. That's where the range begins. We continue up until we find the highest part of the graph. We continue along and we see that the highest output is here at 6. That means the range ends at +6. So the range is all real numbers between -4 and 6, but not including -4. Why not including -4? Well, notice the end point here on the graph at -4. It's an open circle. That indicates that the relation does not include -4 as an output. We can write that using a variety of set notations, but what it comes down to is that the outputs we get from this relation will range from -4 up to 6, not including -4, but including 6. And so now we know all about this relation in terms of the inputs from -4 to 7 and the outputs from -4 to 6. Here's another exercise. Can you determine the domain and range of this relation? Please pause the video here and complete the exercise. Domain is the inputs from left to right along the x-axis. We see the smallest input at -3 and the largest input at +7. The domain is all real numbers from -3 to +7, inclusive. The range is the outputs from low to high along the y-axis. We see the lowest output at -2 and the highest output at +8. The range is all real numbers from -2 to +8, inclusive. Of course, we can write this using any of our set notations. In this exercise, we have another relation. Can you determine the domain and range of this one? Please pause the video here and complete the exercise. Domain looks along the x-axis. We have our domain from -9 up to +4. Notice -9 is not included, as indicated by the open circle on the graph. +4 is included. The range from low to high tells us that the possible outputs are from -8 up to +6. -8 is included, but +6 is not. That's indicated by the open circle on the graph. How about a relation like this? This is a little different because while there is a low part of the graph, we have arrows on the ends which indicate that it continues moving along infinitely. To get a better idea of what's going on, let's zoom out a little bit. Here we see the graph of our relation, f of x equals x squared. When we look at the domain, we're looking from left to right for the inputs. The graph continues moving to the left toward -infinity, and it also continues moving to the right toward +infinity. It will continue moving left forever, and it will also continue moving to the right. That means we can input any real number into this equation. The domain is all real numbers from -infinity to +infinity. How about the range, the possible outputs? We'll start by looking at the bottom of the graph. The lowest point is at 0. But we notice that it opens upward and it doesn't have an upper bound. In fact, it continues toward +infinity. Since the smallest output is 0, but there's no largest, we say that the range is all real numbers greater than or equal to 0, or from 0 to +infinity. We've now determined the domain and range for this function. Here's an absolute value function. Can you determine the domain and range for this one? Please pause the video here and determine the domain and the range. Domain looks left to right. On the left-hand side, we're moving infinitely toward -infinity. On the right-hand side, we continue to move along toward +infinity. The arrows on the ends of the graph indicate that the graph continues to move along in each of those directions. The domain is all real numbers, -infinity to +infinity. You can input any real number into this function and expect to get an output. What outputs can you expect to get? We'll begin by looking at the lowest part of the graph. The bottom of the graph is at -5. That's the smallest output. How about the largest? We notice that the graph opens upward infinitely. Therefore, the outputs are all real numbers greater than or equal to -5, or from -5 to infinity. Here's another exercise. Can you determine the domain and range of this relation? Please pause the video here and complete the exercise. In this exercise, we see that the graph moves to the left infinitely and to the right infinitely, giving us a domain of all real numbers from -infinity to +infinity. The outputs, the range, are also all real numbers. We see that the graph goes downward infinitely and it continues upward without end. That means our range is from -infinity to +infinity. So here's what we know. Domain is the set of input values. In a discrete relationship, we simply make a list of the inputs, and that's the domain. In a continuous relationship, we have to look at the graph. We look left to right along the x-axis to find the lowest and the highest inputs. Range is the set of output values. In a discrete relationship, we simply make a list of the output values, and that's the range. In the case of a continuous relationship, we look at the graph from low to high along the y-axis. This gives us the lowest and the highest possible output, which is the range. This is everything you need to know about determining the domain and the range of a relation.